Hey everybody, welcome to part one of the time value of money chapter. I've broken this up into two parts because I want you guys to do this first part, practice it a little bit, get comfortable with it before we move on to the second one, which is going to add some complexity, obviously. And so let's get right into it. I'm going to assume that nobody who's watching this has ever taken a finance course before. Maybe you have, so maybe some of this will be basic for you. But I want us all to start the same way so that we can progress the same way. Time value of money is basically the math behind everything in finance. So your credit card, your credit card, for example, right? Like when you put stuff on your credit card and you have to pay interest, and when you borrow money, when you save money, when you invest in stocks, when you invest in bonds, like anything that has to do with finance, the math behind it is what we're going to see here. Like why is it that if I put $1,000 into a bank account today, a year from now I'll have more than 1,000? Well, you're going to say, well, you're going to earn interest. Yeah, 100%. But how much interest? Right? That's what we're learning in this chapter. Like, what is that relationship between time, money, right, and an interest rate? And that's what time value of money is. The majority of the work in this chapter revolves around these 5 variables. So let's just talk about them for a second. Present value is the value at a present, or well, I should say this. Present value and future value, these are both lump sums. Okay, let's start with that. A lump sum is a single amount at a point in time. Now, the difference between them is just what point in time. When you look at a timeline, the beginning of the timeline is the present value, and the end of the timeline is the future value. So future value is just some dollar amount in the future, and the present value is some dollar amount in the present day. Now, the present day, you'll learn as we go through the chapters, isn't always today. Sometimes you're finding a present value 5 years from now, okay? But we won't talk about that just yet. The point is that a present value and a future value are both lump sums, just at different points in time, okay? Present day, future day. On your financial calculators, and these are the only 2 financial calculators you should be using. If you're using any other brand, I suggest you return it or give it back to your friend or whatever it is and get yourselves a Texas Instrument BA2 Plus. You can get the one on the left or the one on the right. Doesn't really make a difference. I think the one on the right is like an extra $20. It does a couple of things that this one cannot, but it's not absolutely necessary. You are perfectly fine with that one, okay? But don't get something else. Okay, so present and future values, we talked about them. Now, the next one is the effective rate. This is what we will often refer to as the interest rate, but it's not every time that I say interest rate that is necessarily an effective rate. Again, I'm not going to get into what an effective rate is right now. The effective rate is simply, for now, the rate at which the money will grow, if we're talking about, let's say, savings, the amount of interest that you pay per period, if we're talking about borrowings. It's basically the rate of change of the money vis-a-vis time. Okay, so if I put $1,000 into an account and I tell you that it has an effective rate 5% per year, that means that amount will grow at a rate of 5% per year, or you will pay 5% per year in interest. The button on the calculators is IY, stands for interest per, year. But then you have recurring cash flows. This is a little bit different from lump sums. These recurring cash flows in the context of whatever you're solving are, like it says, recurring. So for example, you will receive $100 per month for a year. Because you're not only receiving that $100 once and there's a string of payments, we would call it a payment or a cash flow or a recurring payment of some kind. And the symbols that we'll use when using formulas vary. But the button on the calculator is PMT. You see it right here. You see it right here. And then finally, the number of periods or the number of payments. That's just N. You've got it here and here. Okay, guys. So your job, especially in this first bit, is going, well, your job is almost always to find one of these. I would say the vast majority of questions, we're looking for the present value. But a lot of times it's the future value. A lot of times the payment. Sometimes it's even the rate or the N. But vast majority of the times, it's the PV that we're looking for, okay? Now, if you don't know how to use the financial calculator, I will be covering it as we work through this, but I also want to invite you guys to watch the financial calculator workshop. It's like a 30-minute video that I posted on YouTube. There should be a link to it directly in this course. it'll help you just practice it a little bit more. I go into some other little tricks that the calculator can do. And so I highly recommend that you guys watch that as well. All right. So let's get into it. Now, everybody knows what interest is conceptually, right? Interest is the rate at which your money will grow, or the rate that you pay when you borrow money. But we have to understand that there's really two parts to that. Okay. There's simple interest and there's compound interest. So simple interest is basically interest on just the original or the principal amount. Whereas compound interest is interest that accumulates not only on the principal amount, but also on other interest. And so to make sure you guys understand that, I'm going to illustrate it. Okay, so imagine that you have $1,000 and you invest it at a rate of 10%, okay? So you start with 1,000 here. This will be times 0. And then 1 year later, you're going to earn 10%. Now, if this were simple interest, 10% of 1,000 is $100, okay? So you would gain $100. So now you'd have $1,100. In year 2, you would have $1,200. In year 3, you would have $1,300. In year 4, you would have $1,400. What do you notice? Every single period, it's growing by exactly 100. That is simple interest, where interest is only earned on the original amount, okay? Compound interest, on the other hand, if I were to illustrate it, so again, you start with 1,000. In the first year, you're still going to have 1,100. Why? Well, because compound interest, the way it works is it pays you interest on whatever the previous balance is. So you started with 1,000. 10% of 1,000 is 100. Okay, so I added 100. But now, if I take 10% of 1,100, that's 110. So now I'll be adding 110, so you'll have 1,210. You see that extra $10 right there? Compare those two. See that extra $10? That's what we call interest on interest. Because if you were to take that $210 and break it up, sorry, this 110 and break it up, 100 of it was interest that you earned on the original, right? So that's the simple interest component. And the other 10 is interest on interest. This interest was earned on this $100 that you got the previous month. Interest on interest. So you see, you got interest on this 100, on this 1,000, and you got interest on this 100. And so now this will start to accumulate. It'll start to compound. That's where the name comes from. So if we look at year 3, now you're going to earn 10% on this, which is 121. So I'm earning, so if I do 1,210 plus 121, 1,331. Let's compare. Right? So instead of only earning 300, or sorry, instead of only earning 100 between years 2 and 3, you earned 121. It's the same thing. So that 121, if you split it up, the first 100 of it is the simple interest that you got paid on your original deposit, and the other 21 is on all of the interest you had earned prior to that year. And so that is the difference between simple and compound interest. 99% of the time, my friends, it'll be compound interest. Always assume it's compound interest. By default, it's compound interest. Everything uses compound interest. The only thing that doesn't use compound interest you'll see is, when you calculate the payment on a bond, not to jump too far ahead, for the coupon payment specifically, we'll use simple interest. Other than that, guys, they would have to be very specific. They'd have to say, this account only pays simple interest, or you borrowed money at simple interest. Fine, then you can assume simple interest because you're being told to use it. Otherwise, always assume interest compounds, okay? Great. So here are some of the formulas that you can use when solving the questions. The first one at the top is simple interest, right? So how do you calculate simple interest? It is the principal amount, that's P, multiplied by the APR, annual percentage rate, multiplied by time. Okay, I'll show you guys how to use that in a moment. Whereas a compound interest formula is a little bit different. You start with the present value, whatever that is, multiply it by 1 plus K. K is your effective rate. Now, I'm going to use K throughout this video, but some of you guys might know this as R. Some of your teachers like to use R. Some of your teachers like to use K. I will use K in this video, but if you prefer to use R, then yours would obviously be like that. Okay, same thing. Cool. So let's we're gonna have an exercise on that in a second. here, let's actually jump ahead to page number 5. So you just deposited $10,000 into an account earning 8% interest per year, and you plan to leave the money in there for 7 years. How much simple interest will you earn? Okay, so simple interest, remember the formula was the principal amount multiplied by the rate multiplied by the number of years. So if you deposited 10,000 and the account earns 8% and you left it there for 7 years, 10,000 times 8% times 7 years is 5,600. That is how much simple interest you earned in those 7 years. Interest only on that principal amount. But if I ask you how much total interest you earned, that's like asking you how much compound interest did you earn. And for this, you need to do a little bit differently. If you want to find out how much interest is earned, like before I show you guys formulas that make it seem more complicated, guys, what is interest? Interest is the money you have that wasn't yours to begin with. Like I put X amount of dollars into my account, and now I have more. That excess is interest, right? And so you want to think of it that way. Figure out how much you have at the end, aka your future value, and then subtract from that whatever money you put in. So if you started with 10,000, and the formula I'm going to use is future value equals present value multiplied by 1 plus k to the n, right? That formula that I just showed you. Well, if you start with 10,000, that is your initial amount. Your account is earning 8% interest for 7 years. So your k is your rate, 8%, and your n is 7. So 10,000 times 1.08 to the 7. You have $17,138.24. Okay, so this is your future value. This means that the $10,000 you started with has grown to become $17,138. And so how much interest did you earn? Did you earn $17,000 of interest? No. That's the future value is the total amount. So you want to subtract from that whatever you put in. So you started with 10,000. So I'm going to subtract 10,000 from this. $7,138.24. That is your total interest, your total compound interest. So now look at question C. How much interest on interest did you earn? Interest on interest refers to, and I showed you guys this earlier, the interest you earned, but only on other interest. So how do we find that? Well, interest on interest is the difference between compound interest and simple interest, right? Like if you were only earning interest on your initial 10K, you would have $5,600 of interest, but you have $7,138. So if you take $7,138.24 minus $5,600, $1,538.24. That is interest on interest. Of that 7,138, 1,500 of it was purely interest you earned on other interest that you earned. That makes sense. Okay, so that's it for that first bit, right? We got warmed up a little bit. So now let's back up and go here. So this is where it really starts to matter, okay? So the first and most basic time value of money operations are finding the present value and the future value of lump sums, of single values. And actually, the example I just showed you a minute ago, we did that, okay? But let's kind of slow down on this. When I have a single amount of money and I want to move it around in time, meaning, I've got $100 today and I want to know how much that will grow into 5 years from now. Or I need to have $10,000 in 5 years and I want to know how much money do I need to save today. When finding the present value or the future value of something, that's all you're doing. You're taking the value at one point in time and just moving it to a different point in time while taking into consideration the interest rate over that period, okay? And so we'll start with the basic one, which is a lump sum, moving one value at a time. Okay, so you would use these formulas that I'm about to show you when you're trying to move or find the present value of or future value of one number at a time. So it depends on a few things. It depends on M, your compounding frequency. Talk about that in a second. It depends on T, which is the number of years. It depends on the number of periods. So that would be N times, that would be N, which is just the number of years multiplied by your compounding frequency. And it depends on your periodic interest rate. So let's talk about this for a second. Why is this even, like, what are we saying here? So let's talk about the compound frequency. Well, if you take an APR, an annual percentage rate of 10%, all this means, guys, is that you have 10% interest per year, but that could be split up into periods. For example, if I say a compounding frequency of 1, that is a true 10%. That means that once a year, you will earn 10% or you will pay 10%. But if I said, hey, you have a 10% annual rate, okay, but your compounding is 2, it means that, yes, it's 10%, but that 10% is split into 2 periods. So it's actually 5% every 6 months. And if I said APR of 10% with a quarterly compounding frequency, it's still 10% if you add it up, right? And that's the thing. If you add them up, you'll always get 10%, but it's actually 2.5% 4 times a year. Now you're looking at that maybe and saying, well, who cares? What difference does it make? Well, it makes a difference because I just showed you guys that when you start to compound, right? When you start to compound, your money starts to grow. And the more often you compound, like here, there was 0 compounding technically. And so I was always earning $100. Here I introduced a little bit of compounding and now I started to earn a little bit more. So the more often you compound, the faster your money will grow. So if we look at just these 3 examples, and let's start with a basic thing. Okay, let's start with $100 in each of these accounts. Well, this one, after 1 year, will have 110 because 10% of 100 is $10. This one does it in 2 steps. First, it's going to earn 5%. So now it'll have 105. Now it's going to earn 5% on this, because remember, that's how compounding works. And so if you take 5% of 105,000, that is 5 point, I know, 5.25. So now, okay, now let's see what happens if we break it up 4 times. So you get the idea. First, we're going to earn 2.5% on 100. So that's $2.50. So now I have 102.5. Then I'm going to earn 2.5% on this. So if I do 102.5, if I want to add 2.5%, I'm just going to multiply that by 1.025. Now I have 105.06. Then again, I'm going to multiply that by 1.025. Now I have, after whatever it is, 3 periods, 107.69. And then if I multiply that once more by 1.025, I have 110.38. So what do you notice, guys? I started with $100 in all 3 situations. All 3 situations technically pay me 10% interest per year, but because here I'm compounding, aka I'm dividing my year into smaller periods, my money grows faster. And so that's why the compounding frequency matters. The present value was the same. The future value is different. Okay, we'll talk about effective rates and all that a little bit later. For now, we're just really introducing the concept. So that's why M here, matters. Okay, cool. So now so K, right? Your effective periodic rate in this case. You see, while technically all 3 of these had the same APR, the K was different. The K, or the R, is 10% in this case divided by M. So 10% divided by 1 is 10%. So that's what I meant when I said it's a true 10%. If you only compound once per year, then you actually earn the rate that they say you earned. Here, though, it's 5%, because if I take that 10% and divide it by 2, it's 5%. And here, if I take that 10% and I divide it by 4, it's 2.5%. But here my N is 1, here my N is 2, and here my N is 4. That's the number of periods. I'm earning 10% one time. Here I'm earning 5% 2 times, right? 1, 2. I'm earning 2.5% 4 times. 1, 2, 3, 4. Okay. And okay, let's start with that. We'll skip continuous compounding for now, just not to make it overly complicated. And we'll start with a few kind of basic examples here just to show you. The formula I will be using is this one here. I'm not going to start using the financial calculator yet because I want you guys to be comfortable using the basic single value or lump sum formulas. Like, yes, I know the calculator is magical and it can do everything and it's great. But this is basic, guys. This is fundamental. You have to know this and you have to be comfortable using it, okay? So I will not start using the financial calculator until we get to the annuities. I will use it once here just to show you how to use it, but then I'm going to revert back to these formulas, okay? So look, you have $1,000 today and you will deposit it into an account earning 8% interest per year. How much will you have after 5 years? So let's break it down. We're asking you how much you'll have in 5 years. That means you're looking, guys, for a future value. So if you're looking for the future value, all you need to do is rearrange this formula by moving this up here. So the future value formula is actually the present value, and we just saw that one a second ago, multiplied by 1 plus k to the n. Okay, remember? Okay, so I showed you that formula here. It's the same formula. So the present value formula and the future value formula are the same formula, just rearranged. And so let's get into it. You have $1,000 today. That is your starting amount. That's your present value. So 1,000, right? Always start with your present value. Multiplied by 1 plus, now the rate. They said 8% interest per year. I want you to compare that to this 9% interest per year compounded monthly. If we tell you, and this part, guys, is so important. I'm going to say it and it's going to seem like I just said something random, but this is probably in the first half of the semester, the question I get the most. Like, how do I know if the rate they're giving me is already an effective rate or if I need to convert it to an effective rate? That is the number one most frequently asked question. Okay, so how do I know if an interest rate is already the effective rate, so it's already the K, or if I have to convert it to the K? Here's the answer, okay? If I give you a rate and I do not mention anywhere a compounding frequency, then that rate is already an effective rate. So 8% here is my effective annual rate. Well, it's my effective rate, and because they said per year, it's an annual rate. Basically, that's K. Compare it here, guys. I said 9% interest per year, and this is the part that students take. Well, you said 9% interest per year in both. Yes, but I never said, the thing I want you guys to focus on is the compounding. In this one, I mentioned compounding. 9% interest per year compounded monthly. That's different. Whenever you see a compounding frequency, okay, you need to actually do the conversion. So here your K is 9% divided by 12. Okay? Not here. Here, this is the K. And that matters because, I mean, it seems kind of easy here when you're doing lump sums, but guys, once you start getting into the more complicated concepts like annuities, perpetuities, loans, and bonds, and stocks, and that is going to be a very, very important element, okay? So in this case, 8% is my K, 0.08. And your N, okay, your N is your number of periods, not your number of years, your number of periods. Now, here, because your rate is annual, this next thing I'm going to say is also really important, okay? Because your rate is annual, 8% per year, your N also has to be annual. Your K or your R, the rate basically, and your number of periods, or the frequency or the unit of time in your N have to match always. So if you're using an annual rate here, your N has to be in years. If you use a monthly rate, like in the following question, your N has to be in months. Okay, we'll get to that in a moment. Anyways, let's punch this in now and see what we get. 1,000 times 1.08 to the power of 5, 1,469 and 33 cents. Okay, so let's jump right into number 2 so you can see the difference. Okay, you just borrowed 10,000. You just borrowed 10,000. Okay, you will have to repay it in a single lump sum payment in 4 years. The lender will charge you 9% interest compounded. Monthly, how much will you repay? It's the same question, okay? We're still looking for the future value because I said, how much will you have to pay in 4 years? So it's the exact same formula. So 10,000 is your present value. But now the rate you're going to use is this. Why? Because they said this. So if you do 0.09 divided by 12, it's 0.0075. Okay. And now your N, so again, because this is monthly, you cannot, I'm going to do it, but don't follow me. You can't put 4 there. N is not number of years. N is number of periods. So you have to do 4 times 12. N is just the number of years times your compounding frequency. It's 4 years times 12, 48 months. Because your rate is in months, so you have to tell me your total time in months. 10,000 times 1.0075 to the power 48. 14,314 and 5 cents. Okay. Now, I'm going to grab the financial calculator because although I want you guys to be doing these by hand using the formulas, you still should know how to do it with a financial calculator. So it works largely the same way, okay? So you're going to have most of the same components. Like your present value here is the 10,000 that we started with. Your N is the same thing, same logic too. There is no payment in this question, right? There was no recurring payment. And so just set that to 0 for now. Now, the way that the rates work on the calculators, the IY, okay, is your APR. It's basically this number, the 9, okay? Now, whenever you're entering a rate into your financial calculator, you enter it as a percentage, not as a decimal. So you enter 9, not 0.09. Now, you have to also mention your compounding frequencies. So the calculator has 2 additional things you need to enter, PY and CY. PY stands for periods per year, and CY is compounds per year. And so when you're doing lump sums, these 2 numbers will always be the same. And in our case, that's just your frequency. It's 12. Okay, once we get to the more advanced stuff, you'll see situations where those can be different. For now, when you're just trying to find the present or the future value of a singular number, these 2 should always be the same. So 12 in this case. And then once you've entered all that, you're going to tell the calculator to compute the future value. Okay, so now let me show you how to actually punch it in. When you want to punch values into this calculator, the first thing you do is you enter the number and then you assign it to a variable. Another thing that's important with present values in general is, I'd say like 99% of the time, you should enter it as a negative number. So this is exactly how I would enter this into my calculator. First, I would press 10,000. Okay, so 10000, and then the plus minus at the very bottom right will change it to negative. So negative. Now I want to assign that to the present value, so I'm going to press the present value button, PV. You don't have to press enter, you don't have to save it, you don't have to do anything. As soon as you press PV, okay, it saves this as the present value. 48, that's your N. Remember, guys, we have a workshop on this. Please watch it where we go into great detail. These are just the basics. 0 is the payment. And yes, I suggest you enter it always. Now, here's the rate business. 9 IY. Okay, step 1. Done. Now, the way that you enter these two is by pressing second function and then the IY button. So look at me first and then you try and do it. So first I'm going to press second function. See right there, second. And then I'll press the IY button because I'm trying to get to that PY. Okay, here. So PY. 12. Now here, you do have to press enter. And I know, that's so annoying. How am I supposed to know what? It's practice. You will know, I promise you will know just after using this calculator for a little while when you should be pressing enter and when you don't need to press enter. It's just practice. So here, one thing I'll tell you is whenever you're in these like secondary menus, these like additional tools, like I pressed second function to get there, you always have to press enter to save your numbers. Okay, so now I'm in this secondary tool of PY, CY, all that stuff. So I'm pressing 12 and then enter at the top of the calculator will save it. Arrow down, CY, sometimes it'll automatically change. Also, great, it's 12. I don't want to change it. If I got to this screen and it was something else, you would do the same thing. 12, enter, okay? So now you've entered both of them. Always double check by scrolling up and down. Look, I'm tapping my arrows just to make sure. Okay, they're both 12. That's what I wanted. So now the calculator knows everything there is to know about the question. You can back out of there. How do you back out of there? To bottom left, the most bottom left button, clear. Just press it once. Okay, now you're out. Doesn't matter that you still see 12 there. You can press it a second time if you don't want to see it. The point is you got out of that screen. And now you press compute, top left. Once you've entered all the values and you want to actually get the answer from the calculator, you need to tell it, hey, go and compute. Press compute, whatever you want. I want future value. And there it is. 14,314. It's the exact same number. So, I mean, yeah, cool. Was that easier? I don't think so. I think this was way more complicated than this. But you have to know it, okay? And that is why for the rest of this portion of this chapter, I will not be using the financial calculator. Once we start to have payments, okay? That is when the financial calculator really shines because the formulas go from being pretty short and basic to, again, I don't want to jump ahead too much, but once we start getting into these guys, then I'm going to say, yeah, you want to use us. That should be okay. Once we start getting into these, I will totally, flip and basically never use any of these except for these and always use the financial calculator. Okay. Again, not to get too far ahead, but that's kind of where we're at. Okay, so I got my future value. Let's do a couple more. You need to save up $50K to go on a tour of the world. You plan on departing in 4 years. How much should you deposit today? Okay, so you need to have 50. So this is different. And I love timelines, guys. You will notice that I love timelines. You need to love timelines. It just helps to have a visual of what's going on. You need to have 50K 4 years from now. Today we're here at time 0. Your account earns 9% interest compounded weekly. Oh, there it is. 9% is your APR. It's not your effective rate. 9% is just your annual rate. But because they said the compounding, you need to adjust it. So my K is actually 9% over 52. And this one I'm not going to punch it in because I don't want to introduce a bunch of rounding, right? If I do 0.09 over 52, I'm assuming it's not going to be a nice round number. It is not. I'm just going to leave it like that. N, the number of periods. Well, if this is weeks, how many weeks are in 4 years? Well, I'll do 4 years times 52. So 52 times 4 is 208. Okay, and then my formula. I know present value, you take the future value divided by 1 plus the K, or R, whatever you prefer, to the N. So 50,000. 1 plus 0.09 over 52 to the power 208. Okay, when you're punching this into your calculator, some of you guys still have trouble with it. If you're going to be doing it all in one shot, you need to put an extra bracket there like that. Okay, so basically 50,000 divided by bracket 1 plus 0.09 over 52, close bracket, to the power 208, close bracket. 34,894. So just to make sure you understand what you just found, very, very simple. If you deposit $34,894.67 today into your account, and that account earns 9% interest compounded weekly, the interest you gain will take you from 34,000 to 50K. You will reach $50,000 exactly in 4 years. This here is the present value of this future value. Okay. Let's do another one. Oh, okay. So for this one, now that you sort of started hopefully to understand compounding, I want to introduce continuous compounding. And so for that, where was my illustration before of the different rates? I lost it. No, I'll find it. Are those 3 10s? Where's it? 10, 10. Did I lose it? Oh, no, here. Okay. So you saw what happened as my compounding frequency started to increase. My money started to grow faster and faster. So, okay, what's the maximum that I can compound? Well, technically, it's infinity. Now, just to try and wrap your heads around that, imagine that your interest was compounded every second, okay? So imagine taking 1 year. It's going to sound silly, but I think you'll get it. In 1 year, so let's say 60 seconds to a minute, 60 minutes to an hour, 24 hours in a day, 365 days in a year. Okay. 1 year has about 31.536 million seconds. Okay. So imagine that your 10% interest was divided by this number, where you were earning basically 0.00000317097 percent every second. It's still 10%, right? But we saw the effect of splitting it into smaller periods and the money grows. And so if you can split it into on a per second basis, this would technically be your rate. And so if you started with, what did we start with? $100, okay? And I gained, guys, you don't have to write this, okay? This is really just, how many zeros do I need here? I would have $110.52. So if we compare now, this is 1 year, by the way, 110, 110, 110. You see, when I went from compounding once to compounding twice, my total amount increased by about 25 cents. Then when I went from twice to 4 times, it increased from 25 cents to 38 cents. When I increased from quarterly to every second, it increased by another however many cents that is. That's essentially what continuously compounding is. Just compounding nonstop. Now, obviously, this is not how we'll do it. And that's why we have better formulas. And the formula for continuous compounding is this. I have it here. Okay. When you want to find the present value or the future value of continuous compounding, you need to use the exponential variable, which is everybody has on their calculators, just E. And so let me show you how to do it. I'll paste it here. Now, depending on what you're looking for, if you're looking for the present value, then you divide the future value. But if you want the future value, then you multiply then you can again rearrange it and multiply the present value. So let's see. You just deposited $4,000 into an account earning 9% interest per year compounded continuously. In 3 years, you'll make another deposit, and in 7 years, your goal is to have $12,000. How much will you deposit in 3 years? This is actually a pretty common exam question, so I want you guys to pay close attention to how I solve it. I started with 4,000. That's today at time 0. 3 years from now, 1, 2, 3, I'm going to deposit another amount. And then in 7 years, so that's year 1, year 2, year 3. And then I'll break that. And at year 7, I want to withdraw 12,000. Meaning, I need this amount to grow into something, and this amount that I'm going to deposit to grow into something, and that has to equal $12,000. So they're essentially telling you guys exactly what to do. The future value of $4,000 plus the future value of whatever this is has to equal 12,000. What is X? Okay. So you want to use a little bit of like just basic deduction. Like every question is going to be a little bit different, but the math will always be the same. And so think about what I just said. Okay, I can find the future value of this, right? So if I were to rearrange this, future value equals present value multiplied by E to the APR times T. Some of you guys may have learned this formula in math, APRT. I don't know if you've ever seen it. It's the exact same formula. I think in like math 208 or 209, we cover that. So I started with 4,000. E, the rate is your rate. That's 9%, 0.09 times 7. So 4,000 times E, exponent 0.09 times 7. Again, if you're doing this in one shot, guys, on the calculators, make sure you put a bracket up there. So this will grow into $7,510.44. That 4,000 alone will become 7,500. Okay. So now, if I know that I need to have 12,000 minus the $7,510.44 that I'm going to have just from that, that leaves me with $44.8956. So what am I saying? This amount here needs to grow into this amount in order for me to reach my goal. So this is the future value, and I'm looking for its present value. So back to here. How many years is it in the account? From 3 to 7, that's 4 years. So I'm going to use this formula. The future value is $4,489.56. E to the R, which is 9, times T, which is 4. This will give me my final answer. The students that struggle the most in this class are the ones that don't spend the time in this chapter to practice these types of questions, and really wrapping their heads around the mechanics of it. I don't want you guys to think that there's like 5 or 6 questions that they just always ask, right? Maybe that's the case in accounting or stats or whatever, but this is really a math class. This portion of it is a math class, and you're learning the math. It's like when you learn calculus. You had to learn how to solve derivatives, but then the derivative they throw at you is always different. It's the same thing here. I'm showing you guys how to find the present value, how to find the future value, but then you need to apply those things to these questions. And so here we started with, we found the present, we took the $4,000, found its future value, and we already knew the story, right? So we already knew that we needed the total future value to be 12. So, okay, this future value was 7 something. I subtracted that from my 12. Okay, so that means that the other future value had to be 44. And then I said, okay, well, if I need to have 44 here, how much did I deposit? So what was the present value of that number? That's it. Okay, 3,132. You see, this formula here is doing what I showed you guys here, where it's basically taking your it's not actually without having to do all this weird math. It's taking your interest, dividing it into an infinitely small amount, and then compounding it an infinite number of times. And just to show you what I mean, if I take 100 times e to the 10 and it was just 1 year, right? 100 times e to the power 0. I get 110.52. So you see how it's the same. All right. Continuous compounding, while it is not very common in real life, it does sometimes show up on the exam, and so you guys need to be familiar with it. Okay. Cool. So we've already solved this question. Let's move on to here. So now we've spent a bit of time talking about effective rates. I showed you guys really that once you start to introduce compounding, that the true rate of growth of your money changes. And so we're going to give that a name now, okay? The APR, which is the rate that doesn't consider compounding, right? Like that 10%, remember here, the 10% every year, 10%, 10%, 10%. It was all 10%. That's what we call an APR. Other names for it sometimes, we call it the quoted rate. We sometimes call it the stated rate. We sometimes call it the nominal rate. Basically, this is the rate, like I said, that does not consider compounding. It's just if you were to add up all the interest rates for the year, you would reach this number. But we've learned now that interest isn't added together. Interest is multiplied together. Interest is compounded. And so the effective rate is the true rate of interest once you take into consideration the compounding. So if I go back to that example, sorry for flipping back and forth like this, here, the true rate was 10%. But here, the true rate was 10.25. If you compare where I started to where I finished, I actually made, in 1 year, 10.25%. If you compare here where I started to where I finished, that year I actually made 10.38%. And if you look at this one from where I started, to where I finished, I actually made 10.52% that year. That is what we call an effective annual rate. The true interest rate over 1 year. Now, I'm talking about the effective annual rate because that is the most common one. But the thing about effective rates is that you can have an effective monthly rate, you can have an effective weekly rate, daily rate, quarterly rate, every 2-year rate, every 5-year rate. Like there is no, you can have an effective rate that goes with any period of time. Okay. So this is where it starts to become a little bit more complicated. The effective rate is based on two things: your compounding frequency, M, and your effective or payment frequency, which is F. On the financial calculator, your compounding frequency, I already showed you guys this, was CY, and your effective frequency is PY. And up until this point, I said that they're the same. But the moment that you start to have payments, and from this point onwards, we will introduce the fifth variable, which is payments. As soon as you start to have payments, guys, well, now your M, your compounding frequency, and your payment frequency might not be the same. It's very common to have a situation like your payments are monthly, but your interest is compounded semi-annually, where your M is 12 and your F is 2. So what do you do? Okay, that's what we're getting into here. So one little pro tip: when the two are the same, so if your compounding frequencies, that's CY on the calculator, or your payment frequency, which is F if you're using a formula, or PY if you're using your calculator, if they are the same, then you can just divide like we've been doing thus far. Okay, but if they're not the same, guys, here are the new formulas. I would say this one and this one. These are the two that you will use the most often, but they'll probably be given to you on your formula sheet. In column 309, they're given to you for sure. In column 221, you get to make your own formula sheet, so then it doesn't matter. So those will be given, and they're the most common. This one here likely will not be given to you. It's also pretty rare. It's how you find the effective annual rate when you have continuous compounding. Okay, this is wrong here. Let's just say continuous. Okay, See if I can fix that on yours. Okay, so it should be fixed on yours. And then the last one here, this is a formula that your teachers probably will not show you. It's one of my favorite formulas. You absolutely need to memorize it if you're in Com 309 because it won't be on the formula sheet. If you're in 221, put it on your formula sheet for sure. If you're in any other finance class, right, depends. I doubt your teacher will give it to you. So if you're given a formula sheet, you need to memorize it. If you get to make your own, definitely put it on. This is called the effective to effective formula. It is super, super useful when you have an effective rate. Like, let's say they give you an effective monthly rate, or they give you a monthly rate, but you need a weekly rate. It's how you convert a rate from one frequency to another. We'll get to that. Okay. So these are the 4 formulas we'll be working with. If there was one, I would say, like, is the least important by a mile, it would be this one. Okay. But the off chance is there, you guys should still technically know it. So let's get into it. In this exercise, we're just going to be playing with the interest rates. And why this is a really, 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 really important part is this is foundational to every question. It's not that you're going to get questions that are just, about the interest rate. You might, but every single question you solve has an interest rate in it. And so every single time you're solving any question, whether it's to find the present value, the future value, the payment, or whatever it is, first thing you have to ask yourself is, do I have the effective rate? And what I'm showing you guys in this exercise is, how do you find those effective rates? So we'll start with the basic one, okay? What is the effective monthly rate of 12% APR compounded daily? Okay, so let's dissect that. This here is your APR. It's your annual rate, and it's compounded daily. Compounded 365. That's how many days in a year. So remember that example with my 10%? Now imagine I chopped it into days. 365 times. And I want to find an effective monthly rate. So I'm asking you for an effective rate of 12. An effective frequency of 12. See how they're different here? Now, how do I know F is 12? Well, in this case, they said, find an effective monthly rate. They told you that they want the rate to be monthly. That's what we call the effective frequency. So when these two are in them, to go back to these, okay, when do you use each one? Well, look, you use this one when your F is 1. Okay, the annual rate is when your F is 1. You use this one when your F is not 1. Okay. So, and all 3 of these, you use it anytime you're trying to convert an APR into an effective rate. The fourth one, guys, remember, this one is a special one. This one is when you're trying to go from K old to K new. When you have an effective rate, but it's just like the wrong one for what you're trying to do or whatever, right? So that's a completely different situation. Okay, back to this. So now because your M and your F, because your F is not 1, this is how you find the effective rate. Okay, so you see you can't divide, and this is the step in the previous exercises that we did that I said, oh, you take your 12% and you divide it by your M or whatever. You can't do that here because they're different. So 1 plus the QR is the APR. So 12% divided by your compounding. So 365 to the power M over F, 365 over 12 minus 1. Okay, so you get 0.01005, which if you multiply that by 100, just to see it as a percentage, is 1.005%. So what exactly did we just find? Well, you found that, or how you would interpret this, is that if you had an account that earned 12% interest compounded daily, that is equivalent to or equal to, or it's effectively 1 point, oh, sorry, this is per month, 1.005% per month. If you take 12% and just divide it by 12, because you're like, oh, well, I couldn't have just done that, you'd say it's 1% per month. It's close. It's not the same, right? If you just divide it by 12, because you're like, oh, well, it's 12%, I want to know a monthly rate, I'm just going to divide it by 12, you will get close. Yes, 100%. But you'll be wrong. And in a multiple choice exam, which is what you guys are faced with, you're getting 0, okay? You have to consider both the frequency, yes, but also the compounding. Okay, let's do another one. What is the effective semi-annual rate? Okay, so semi-annual is 2 times per year. One really common question I get is, why is this 2 and not 6? Isn't it every 6 months? Yes, it is every 6 months, but that's not what that means. When you're finding your F, the question you're asking yourself is, how many periods in a year? Well, if you split it up your year into 6-month periods, you would have 2 of them, right? Semi-annual means you take your year and you cut it in 2. The same way that for monthly, I put 12, because there's 12 months in a year. If you took your year and you divided it into monthly periods, you would have 12 periods, right? So semi-annual, really common one, is 2. 7% compounded every 2 years. Your compounding frequency and your effective frequency, for that matter, can actually be longer than a year. Okay, this is what you do. Anytime you have a frequency that is longer than 1 year, it's a fraction. You just do 1, always 1, over whatever number of years. So 1 over 2. So if you don't like fractions and it's nice and round, you can use a decimal too. That's fine. But here you would have a compounding of every 2 years, meaning an M of 1/2. Okay. And so again, here, because the F is not 1, we're going to use the same formula as before. So 1 plus your QR of 7% over your M of 1/2 to the power M over F minus 1. So I get about 3%. So if you multiply that by 100, so I get 0.0333, which if you multiply by 100 is 3.33%. And that is not per year, right? It's an effective semi-annual rate. So let's say per semi-annual, or I'll say per half year. So your true rate of interest is 3.33%, basically every 6 months, every half year. You see, it's not the same. If I would have taken 7.2 divided by 2, you get 3.5. It would be close, but it wouldn't be the same, right? Okay, another one. If you're faced with a question that has an effective frequency that is longer than a year, so an effective 3-year rate, now it's your F that would be a fraction. So your F would be 1 over 3. 10% is the APR compounded monthly. Your M would be 12. And again, same deal, guys. Here, your F is not 1. And so to find your effective rate, to find your true rate of interest, we're going to use this formula. 1 plus the QR over M to the power M over F minus 1. If you're going to use your calculator, you're going to have to use a lot of brackets. I mean, if you're going to use your calculator one shot, you'll need a lot of brackets here. So bracket 1 plus 0.1 divided by 12, close bracket, to the power, open bracket, 12 over, open bracket, 1 over 3, close bracket minus 1. So I get 0.3482, which is about 34.82% every 3 years. That, if you're looking at that and saying, oh, that's really high, well, don't forget, it's 10% per year, but then I'm asking you what are you earning every 3 years? So it makes sense that it's, you know, almost triple that. It's actually more than triple that because of the compounding effects. This is 1/3 here. It's not like super clear, but 1/3. Okay. Let's keep going. What is the effective annual rate of 8% interest, APR compounded continuously? Okay. So this is where we get into this formula. As soon as we say continuous compounding, then you know there's going to be an E somewhere in your work. So when you want to find the effective annual rate of continuously compounded interest, it's very simple. E to the power whatever the APR is, in this case 8%, minus 1. That's it. E to the power 0.08 minus 1. You get about 8.33% per year. So remember that example from earlier? If I take 8% and I divided it into tiny, 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 tiny little pieces, like every second, and then I spread that out over a year, it would work out to be 8.33%. Okay, now this is the one that I really like, which is going from one effective rate to another. So here it's going from K quarterly, put like K quarterly, as a monthly rate. Or a EQR, effective quarterly rate, we want it to become an effective monthly rate. This is where you would use that fourth formula, the effective to effective. Okay. So the only thing you really need, guys, is to identify the old F and the new F, the old frequency and the new frequency. So the old frequency here is 4 because my old rate was quarterly, and the new one is 12 because I want a monthly rate. And then that's it. You just plug it into this formula. This is a very, very useful formula anytime you want to change a rate from one frequency to another. So 1 plus the old K, right, the old rate, which is 2.2%, 0.022. Old F divided by new F minus 1. So you get about 0.0073, which if you multiply by 100 is 0.73% per month. So 2.2% every quarter works out to about 0.73% every month. You see, in this case, no compounding was needed because I wasn't trying to go from an APR to an effective rate. Here, I'm trying to go from one effective rate to another. Okay, so the first 5 exercises that we did here, these will not be standalone questions. This will just be like part of the work of some larger question. One of the most common standalone interest rate questions I've seen, though, is this one here. So a bank is offering its clients a savings account with an APR of 8.5% compounded bi-weekly. Bi means every 2. So bi-weekly means every 2 weeks. That means that your compounding is 26, because if you take 52, there are 52 weeks in a year, and you divide it by 2, that would be 26 periods. So it's offering its clients a savings account with an APR of 8.5% compounded 26 times. It would like to offer another account that is equivalent to the first one. So in order for 2 rates to be equivalent, it means that they must have the same effective rate. For the 2 accounts to be actually equivalent, then they must have the same effective rate. Okay? But this one has monthly compounding. What should the bank quote? So what is the APR, or the quoted rate, on the second account? So really all you need to remember is what I said. For 2 accounts to be equivalent, they have to have the same effective rate. So I would always suggest here you use the effective annual rate formula. So 1 plus QR over M to the M minus 1. Okay, this is the effective annual rate formula, EAR. And they're essentially saying we want the two to be the same. So if you take the first one, because you have all the information on it, 1 plus 0.085 over m, which is 26, to the 26 minus 1. Like if I punch this in, this will give me the effective rate. And I want the second account to be exactly the same. But I don't know the QR. That's what I'm solving for. But it has monthly compounding. Okay, guys, this is the logic to solving this question. You are trying to find two quoted rates that are equivalent once you take into account the fact that they have different compounding frequencies. And so all you need to do is solve this. Now, while this might look algebraically difficult, this entire thing is just one value, right? So you can punch that. I would start with that. Punch that into your calculators. So this is 0.08315. Okay, and then you keep working it down. So we're going to add 1 here to get rid of that. So you have 1.08315. To get rid of a power 12, easiest way would be just putting the other side to the power 1 over 12. That eliminates this. Okay, so now I have this, and you could subtract 1 to get rid of that. So now you have 1.08315 to the power 1 over 12 minus 1. So now I've got 0.006678 equals QR over 12. And then just cross multiply that 12 into it. .01%. That's it. 8.01% would be doesn't make sense though. So something's bugging me. Let's see. Let me go back a few steps. Oh. Yeah. Okay. Okay, so this gives you 0.088566. Okay, this whole thing here. And okay, so now we're going to add 1 to get rid of that. So I have 1.088566. 1 plus QR over 12. To get rid of an exponent 12, which is what you want to do next, you need to put this side to the power 1 over 12. That gets rid of it. And then you can right away from that subtract 1 to get rid of that. So we're doing 1.088566 to the power 1 over 12. And then on the result, take away 1. So now I've got 0.007097 equals QR over 12. And you cross multiply that into here. 8.51. So in order to reach an equivalent rate, the second account has to quote a slightly higher rate because it doesn't compound its interest as often. So in other words, 8.5% compounded biweekly is the same as 8.516% compounded monthly, right? They work out to the same thing. Okay, so really important stuff here, guys. And it's almost worth, like, I mean, we're going to continue in a second, but in order for you guys to really start to understand what's going to happen next, you need to understand what just happened. And so taking the time to go back over it, just to make sure you understand, you know, when can I just divide like we were doing earlier, right? Where you could just say, you know, QR divided by M, or when do I have to use these formulas? And the rule was when your M and your F are the same, you can just divide. When they are not the same, you need to use these formulas. And then when to use each formula depends on what they give you in the question. If your F is 1, you can use the first one. If your F is not 1, you can use the third one. If they say continuous compounding, then you use the middle one. So going back and watching that segment of the course, I think is going to be super important. Now, I'm assuming you did that because we're going to move into the next part. So the last part of this the first part of your TVM is understanding what are annuities and what are perpetuities. And here's where we start to introduce, or here's where we will introduce the payment, which is the fifth of the 5, TVM variables. So an annuity is what we call a recurring cash flow that has an end date. I'll show you an image. Okay, look here. This is an annuity. It's a $100 cash flow every period for 5 periods. Now, what makes this an annuity? Well, a couple of things. 1, it ends at some point, right? It doesn't go on forever. 2, the payments are constant. It's the same payment each time. The time between each payments are constant, like that, right? The times between each one are constant. And the rate of interest over this entire period is also constant. You don't have to write that. It's all written here, basically. Equal payments, equal interval of time, constant and finite. That is the definition of an annuity. So if you're solving a problem, and in the context of the problem, all of these conditions are met, then you are dealing with an annuity. And there's like a set of formulas and a set of techniques that you employ when you're dealing with an annuity. A perpetuity is the exact same thing, except it doesn't have the last rule. A perpetuity is an annuity that goes on forever. So imagine having $100 per year forever. Okay, so again, it is all, when you're reading your questions, it's going to be super important that you establish, am I dealing with an annuity? Am I dealing with a perpetuity? Is this a lump sum? Is this a growing annuity or a growing perpetuity, which we'll see in part 2 of the TVM lesson? Okay, so, and this is where it starts to get complicated because you need to have a system in your mind that filters down based on the different elements given to you in the question, because you'll see that there's 10 different present value formulas. So which one do you use? Well, it all depends on what type of cash flow you're dealing with, okay? So within annuities and perpetuities, the other thing that matters, guys, is the timing of the payment. What do I mean? Let's compare this image to this one. What do you notice? In this one, the first payment is at time 0. In this one, the first payment is at time 1. Why is that? Well, when you look at a timeline, guys, this here represents the first period, right? Obviously, but this is the beginning of that first period, and this is the end of that first period. Technically, they're still the same period. Technically, both of those are like the first year. But one of them is the beginning of the first year, and the other part is the end of the first year. So if your payments happen at the end of each period, we call that an annuity. We call that an ordinary annuity. That is kind of the default. It's the standard. You should always assume that payments are at the end, unless we tell you otherwise. But if the payments occur at the beginning of the year, we call that an annuity due. Now, if you're looking at that, say, well, there's a payment in both. Yeah, technically, this is also the beginning of the second year, right? And the beginning of the third year, and the beginning of the fourth year. What you'll notice is that there's nothing. You'll notice that there's nothing here, because the payments are at the beginning of year 1, the beginning of year 2, the beginning of year 3, the beginning of year 4, and the beginning of year 5. Whereas here, it's the end of year 1, the end of year 2, the end of year 3, the end of year 4, and the end of year 5. So one is an ordinary annuity. This one here. This one is called an annuity due. You should never assume something is an annuity due unless we tell you, okay? Unless we specifically tell you. And a lot of times, even if we tell you, you can almost always solve a problem as ordinary. It is by far the one you will use the most often, but I'll still show you both. Okay, now when you're actually, okay, so now that you sort of understand what an annuity is and how the timing matters and all that, let's introduce the present value and the future value. When you look at something like this, we learned already how to find the present value of a single number, right? Like if I said, find the present value of this $100, you'd say, okay, well, the $100 is a future value. I'll divide it by 1 plus my rate. Let's use a rate of 5%. And this is going back just 1 year. That would be like to the power of 1, right? So that would be 100 divided by 0.05. But about $95.24. And then if I said, okay, do the same thing with this one, you do the same, but then you would change the exponent, right? You'd say, okay, well, that one is in 2 years. And so its present value is $90.70. And so on and so on and so on. So if I said, well, what is the present value of this entire timeline? If you only had the first kind of techniques I showed you, it would be a pretty long equation where you would have to basically add all of their respective present values and say, well, that's 432 and 95 cents. Okay. Yeah, technically that works. And I never want you guys to do it this way necessarily, but I want you to understand that whenever you're finding the present value of an entire timeline, this is technically what you're doing. But because a timeline could have hundreds of periods, this is obviously not how you're going to do it. This would take forever. Like here was only 5, not so bad. But imagine you had 1,000 periods, you'd be dead. So that's why we have these formulas. These formulas that you see here basically do this, but in one shot. So let me show you, for example, since this is an ordinary annuity, the present value of an ordinary annuity is this here. Okay, so that says R there. That should be K, but whatever. So if I were to show you guys this formula, you take your payment, which is the recurring cash flow, multiplied by 1 minus 1 plus the rate, in this case 5%, to the power negative 5 over 5%. Okay, so we're not changing what K means. We're not changing N. All of the rules from before still apply. You get 432 and 95 cents. So you get the exact same number. But it would take the same amount of time to do 5 periods as it would to do 5,000 periods because you would just change your N. And so that's all these formulas are doing. They're just taking the present value or the future value of each individual payment and putting them together. Now, your financial calculators are also very good at doing this. So if we were to solve this exact same one on the financial calculator, just to kind of show you. Okay, let me pull the calculator out. So now I have a payment of 100. So you'll enter 100 and then tap PMT to save it. The rate is 5, so 5 is the IY. N is also 5, so N5. I'm looking for the present value, so I'll set my future value to 0. And one thing that's going to be important every time you start a new question is your PY and your CY. So if you hit second IY, you'll notice that these are both set to 12. That's because the last time I used the calculator, I changed it to 12, but I'm not trying to use 12 here. If you're not trying to use PY and CY, or if you don't need to use PY or CY, you need to make sure that you make them 1. Quickest way to do that is by pressing second clear, and it just resets them to 1. So you can back out of there now and press compute PV, and you get the exact same number. So I'm going to write down what I did. 100 was my payment. 0 future value, because I didn't have one in this question. 5 was the IY. 5N. PY and CY were both 1. I didn't need them. And then I computed the present value, and I got the exact same answer. So 3 different ways to solve the same question. My favorite way when dealing with annuities is the financial calculator. But it's really up to you. Okay. So let's do a few exercises. Oh, here's something that comes up conceptually sometimes. When you're dealing with annuities, okay, if you have 2 different annuities, well, if you have 2 annuities that are the same, meaning exact same payment, like what you have in this image, the same payment, the same number of payments, but the only difference is the timing. An annuity due will always have a greater present value and a greater future value than an ordinary annuity. Why? Because you get the payment 1 year sooner, you get to accumulate more interest on it. That's the only reason. As soon as you have, the faster you get your money, the better it is. And so by getting your payment at the beginning and not having to wait till the end, you get 1 extra year of interest. Okay. All right, let's do a few exercises on that. So what is the present value of an annuity that pays $500 per month? So let's start breaking this down. First thing you want to spot is the frequency of the payment. So $500 per month, that's the frequency of your payment. That's F. So F is 12. 5 years. Okay, that's your number of, that's T, that's your number of years. The interest rate is 7% compounded daily. Remember what I said? If they give you a compounding frequency, then the rate you have is an APR. And so if you're going to use the financial calculator, okay, you have to consider all these things. Well, you have to consider all these things no matter what calculator you'll use. Okay, so here, 500 is your payment. Your N is 5 times 12. When you're dealing with annuities or perpetuities or whatever, your N is the number of years multiplied by the number of payments per year, right? By your F in this case. So 60N. 7 is your IY. Your PY, that's F, right? So this is PY, payments per year, so 12. And your CY is your M, your 365. We're looking for the present value. So you make your future value 0. And then you compute PV. Okay, let's go. $500 payment, 60N, 7 IY, and then second IY, you want to set your PY to 12. So 12, enter, down, 365, enter. And then you just check that they're both correct. Good. Clear to get out. 0 FV, compute PV. 25,239.10. That's the present value. That's the present value of every single one of those payments. Those $500 payments 60 times. If you were to take each one's present value and add it up, you get 25,239. Okay. Now for a perpetuity, technically you cannot do a perpetuity on the financial calculator because a perpetuity is an annuity that doesn't have an N, or the N is infinity. And so you have formulas instead. To find the present value of a perpetuity, you take the payment and you divide it by your effective rate. So let's break it down. $600 per week. So that's your payment. And the per week, that's your F. So 52. Your interest rate is 8%. That's APR. And is compounded weekly. So 52. They're both the same. Interesting. So I know that this is the formula I have to use, but first I have to make sure, do I have my payment? I do. I have 600. And do I have K? And this is where the filter system starts. Okay, I know I have APR, so I need to convert it. Okay. So now my M and my F are the same. So it's like, okay, do I convert it using the long formulas that I learned here? Or do I use this? Well, I can use this. But actually, I want to show you. You can use either one. So if you don't want to worry about if you don't want to worry about the shortcut, I'll say use this. So okay, F is not 1, use this formula. Okay, so you're going to grab your formula. And that's what I was saying. This is a step in a question. It's not a question on its own. Okay, this. So 1 plus the QR of 8% over M, which was 52. 52 over 52 minus 1. Okay, so 1 plus 0.08. 52. Okay, so I got here 0.001538. Or you could have noticed that your M and your F are the same and then just divided. Why? If you look carefully when they're the same, they cancel out here. These ones cancel out and you're left just with that. But I mean, it's a great shortcut, but it's not necessary, right? So I'm going to plug in my 0.001538 down here. So the present value is $390,117.04. That is the value today of $600 every week forever. And this for some people is a sticking point. They're like, I don't get that. How could that be? If it goes on forever, how could you put a value on it? Isn't the value infinity? Fair point. But you have to understand something about time and money. Take your $600 and let's keep it simple. Let's say it's $600 per year, okay? That's $600, and let's say we're using a rate of 10%. The present value of that today, if I were to use my basic calculation, the present value of that today is about $545. Right? Okay. No one should have a problem with that. The $600 in 2 years, if I were to find its present value, $495. Okay, great. Still, nobody should really have a problem with this. But what I want you guys to pay attention to is the fact that it decreased. And this will happen forever. So now let's jump ahead to time, because it's going on forever, right? Let's jump ahead to time 50. This is time 2, time 1, time 0. Let's go to time 50. So that would be 600 divided by 1.1 to the 50. $5. That payment of $600 in 50 years today is only worth $5. You see it's getting smaller. Okay. Jump ahead to period 200. What do you think is going to happen at some point? At some point, those future payments will be completely worthless. And so that is why we could put a value on it, because once those payments turn to zero, the total value of your cash flow stops going up. So if I were to take 600, right? If I use my formula here, present value equals payment over K. I've been using a payment of 600 and a K of 10%. Technically, if I were to add up the present value of every single payment, it would stop increasing once it hits 6,000. Now, technically, it doesn't ever stop increasing because that number will, if you have 10 decimal places and 15 and 20, it essentially will get infinitely closer. It'll be like 5,999.9999999 like forever. Imagine like the 6,000 is sort of an asymptote. I don't want to get too far into the math side of things, but that's the logic, guys, that at some point your payments are just not worth anything. Their present value is 0, and so the value stops going up. So if ever you're bothered by how could you put a value on something infinite, that's what I want you to think about. Okay, so we saw annuity here. We saw perpetuity. There's a hack on your calculator. I don't love it, but just to show you. If I were to solve this question, 600 payment, 8 IY, second, and I make both of these 52, okay? 0 future value, but I make my N 99999999999, like I fill my screen. Like it works technically, right? Like that is the true present value. The reason we got a slightly different number is because of rounding. So the argument could be like, oh, well, isn't this better? I mean, yeah, probably. So how can you solve a perpetuity on your financial calculator? Solve it exactly like an annuity. By the way, the teachers don't love this, and that's why I'm saying like I don't love it. I actually do like it a lot, but if you're solving a multiple choice exam, it's beautiful. Just make your N, just fill your screen with 9s, okay? Yeah. Okay, number 3, you will deposit $1,000 into your savings account each quarter for the next 10 years. So let's break it down. And I'm solving a bunch of these because I want you guys to see how my brain processes the questions, because I need you guys to start processing them in the same way before you start to develop your own style. You'll deposit $1,000 into your account each quarter. So that's your payment. Each quarter, that's the frequency. So F is 4. For the next 10 years, that's your T. How much will you have saved up at the end of the 10th year? So what is the future value, in other words? If your account earns 9% interest compounded monthly. So 9% is the APR. Compounded monthly is your M. Okay, so first thing is I need my rate. My M and my F are different, and so I'm going to use the rate, the formula I've been using before, QR over M to the M over F minus 1. So 1. Actually, no. We're not going to do that. We're going to use the financial calculator. Sorry. Cut, go back. Okay, so now we need to figure out what are we dealing with. So your payments are constant and they end after a certain amount of time, which means it's an annuity. And the moment you get to, oh, this is an ordinary annuity or even an annuity due, the financial calculator takes over. So we're going to enter 1,000 as the payment. Our N is 10 years times 4 quarters. We're going to make 40, so 10 times 4, 40 total deposits. The account earns 9%, but your PY and your CY. So PY is your payments per year. That's your frequency, so that's 4. And your CY is your compounding frequency, so that's M. We're looking for the future value this time, so the present value is 0, and you'll compute the future value. And this is equivalent to finding the future value of every single one of those 40 payments and adding them up. So let's go. 1,000 payments, 40N, 9 IY, and then you press second IY to get here. 4, enter is your PY, down. 12, enter. And then you just check that they're both correct. Good. Clear to get out of there. 0 PV, compute FV. 64,023 and 38 cents. That is how much you'll have in 10 years. Okay, great. That's I think there's a couple more for us to do here. Okay, great. Yeah, this is what I was looking for. You just want a lottery that promises to pay you $30,000 per month forever. Okay, so $30,000 per month. 30,000 is your payment. Per month is your frequency. So your frequency of the payment, so 12, and forever makes this a perpetuity, right? The first payment is today. And this is interesting. This makes it a perpetuity due. Because if you were to draw that on a timeline, if the first payment is today, today is time 0 here. Okay? So I showed you guys this earlier. When the first payment occurs at time 0, in other words, at the beginning of the first period, it's a perpetuity due. So without even reaching the end of the paragraph, I know what I'm dealing with. I know this is a perpetuity due. Someone has offered to buy the ticket from you. What is the amount? What is the amount you would accept? So in other words, what is this ticket worth today? We're looking for the present value. To find the present value of a perpetuity due, the formula is PMT over K multiplied by 1 plus K. And that's actually something I want to talk to you guys about for a second. If I go back to the list of formulas over here, you'll notice that every time it's due, it's actually the same formula as ordinary, but we multiply it by 1 plus K. Like compare these two. They're the exact same formula, but the due, you multiply it by 1 plus K. Same thing with future value. Same formula, but due, you multiply it by 1 plus K. Perpetuity, same thing. It's the same formula, but you multiply it by 1 plus K. Why? This 1 plus K basically adds 1 year of interest. That's what that does mathematically. And why does it do that? It's because what I said earlier, that by getting your payments 1 period sooner, I shouldn't say year, sorry, it adds 1 period of interest. By getting your payment 1 period sooner, you earn, or you pay, depending on who you are in the story, 1 more period of interest. That's all there is. And so that's the big difference between an ordinary cash flow and a due cash flow. It's just 1 extra period of interest. So if you're using your formulas, you just multiply it by 1 plus K. If you're using the financial calculator, you turn on something called BGN. BGN is a setting. So I'm going to show you guys both. So if you're going to use the formulas, the first thing is you got to establish your K. All right, so what is my K here? I know that this is per month, and I know that my interest is also compounded monthly. So we know that when those two are the same, you can just take your 10% and divide it by the rate. Okay, so that's my K in this question. And so now the present value would just be the payment of 30,000 divided by divided by K, which is 10% over 12, and then multiply that by 1 plus 10% over 12. So K is 10% over 12. Again, I'm punching it in this way just to not have any rounding. So 30,000 divided by 0.1 over 12 times 1 plus 0.1 over 12. So I get 3,630,000. This lottery ticket is worth 3,630,000. Okay. So in the next question, I'll show you guys how to use BGN because I think the next one is an annuity. So number 5. You are going to save $100 at the beginning, there it is, the beginning of each week for the next 35 years. Your goal is to save up enough money so that you can retire comfortably. Your account earns 0.1673% per week. How much will you have on the day you retire? So, a couple of things here. $100 is the payment. They said the beginning, which makes this a due cash flow. Each week, so you're making your payments weekly, so your F is 52. Your frequency is 52. Your T is 35 years. Then when you get to the rate, here's the interesting bit. They didn't say anything about compounding. Instead, they said per week. This is actually already your effective rate. This is an effective weekly rate. So they've already given you K. So we are looking for the amount you're going to have when you retire. What is your future value? So on your financial calculators, 100 is your payment. Your N is going to be 52 times 35 because you're paying 52 times per year because it's weekly for 35 years. So 1,820 is your N. .167. Okay. Now, actually, before I talk about this bit, this is where practice, I'm going to start off by saying this is where practice really matters, okay? In this question, I cannot use PY or CY. I can't use PY, CY. Why? Because I don't have an APR. So when you're using your financial calculator, there's really two situations, and you have to be aware of both of them. If you are given an APR in the question, then your IY is the APR. Your PY has to be set to whatever F is, and your CY has to be set to whatever M is. Okay, that's the scenario we faced already several times. If you are given the effective rate already, so if you're already given K, then your IY is K, your PY is 1, and your CY is 1. Basically, we don't use them. And it's really hyper important, guys, that you identify which one it is. And how, remember what I said at the very beginning of this video, it's all about how they word it. If I say 10% interest compounded monthly, I just gave you an APR, you go this route. But in this question, if I said 0.1673% per week, never mentioned compounding. In fact, I even told you this is a weekly rate. I gave you K. We're going to take this approach. So I'm going to enter that as my IY. So 0.1673 is the IY with a PY of 1 and a CY of 1. We're looking for the future value, so you'll make your present value 0. And you're going to turn on BGN. BGN is because it's a due cash flow. All of this, the order, by the way, doesn't matter. You can press these in whatever order you want. The last thing you do is you compute future value. So let's go. First of all, to turn on BGN and then to turn it off. Okay, it's the same 4 keys. Watch. Second, payment, second, enter. Second payment, second, enter. Look what happened when I did that. You see BGN at the top of the screen there, right? Even if I clear it, BGN remains. That is how you know that it's turned on. So now anything you solve in the calculator is solved as an annuity due. So now you do 100. Now I'm going to enter all this stuff. 100 payment. 1820 is my N. 0.1673 IY. Second, make sure that these are both 1. So 1 and 1. They're good. Get out of there. 0 PV compute FV. You'd have 1,194, 685.86. If you forget to turn on BGN, you could do everything right. And you'll get a number that is close. And I bet you that'll be one of the choices, but it'll be wrong, right? Because you forgot to turn on BGN, so now the calculator solved it as if the payments were at the end of the period. Okay. So 2 really important things we learned in that chapter. BGN, how to turn it on, in this question, BGN, how to turn it on and off, and what to do on your calculator if you're given the effective rate. Okay. 6 is a continuation of 5. It says, how much can you withdraw from your savings account 1 month after retiring if you wish to make equal monthly withdrawals for 25 years? So we retired with this amount. Okay, so now we're here, right? At the beginning of our retirement, we have 1,194,685.86. And it says that 1 month from now, you want to pull money out. And you want to be able to make those withdrawals every month for 25 years. So 25 times 12 is 300. You want to be able to make 300 withdrawals. How much can you withdraw? No, you don't just divide by 300. That would be super, super easy. This is a really common situation with retirement questions. Once you know how much you have on the day you retire, that becomes the present value for this segment of your life. And so, a couple of things. Let's break down the question. 1 month after retiring is when you're going to take out your first, right? So look at your first payment. Your first cash flow is actually at the end of the first period. So now this is it back to being ordinary. We're not going to have BGN anymore. Your account is still earning this per week, but your withdrawals are monthly. And this is another thing that happens a lot with retirement questions, is that the frequency of your savings, like while you were working and saving, doesn't necessarily match the frequency of your withdrawals when you retire. So what happens here is you have a weekly rate. You have a K weekly, but you actually have to convert that to a monthly rate. Why? It's a very important rule when you're dealing with all of these types of questions, is that your K, your effective rate, has to match, right, the frequency of your payment. So here you had an F of 52, but in this portion of your life, your payments are monthly, right? Your F is 12 because you're going to make monthly withdrawals. So it doesn't work if you can't use the 0.1673. Where is it? Hold on. Monthly withdrawals. So your F is 12. So you have a rate, but you have the wrong one, because this rate is based on an F of 52, but you need an F of 12, which is where that effective to effective formula comes in handy. So remember the effective to effective, you take the old K that you have, exponent old F over new F minus 1. So 1 plus 0.001673, old F over new F minus 1. 0.0073. That's your new K. If you want it as a percentage, multiply by 100, it's 0.73. If you want to keep more decimal places, it's 72699%. Okay. Great. And then you're solving for the payment, right? They say, like, what is your withdrawal? So I would set this present value. So always take the amount you have at the retirement, that becomes your PV. The IY is the rate we just found, 0.72699. That's the IY. And again, my PY is going to be 1 and my CY is going to be 1. Again, because I'm entering my effective rate as the IY. And so in that case, you don't use PY and CY, right? The thing I just told you. 300 is your N, because there's 300 total payments. There's future value has to be 0 because you want to run out of money at the end, and then you compute the payment. Okay, so let's punch this all in. So this number, oh, that was wrong, right? So 1194685.86 is your new PV. Notice how I don't have BGN on. Turn it off if you still have it on by pressing the same 4 buttons. Second payment, second enter. For this part, we don't want to have it on because we said that this is an ordinary annuity. 0.72699 is the IY. Again, your PY and your CY need to be 1. 300N, 0 future value, compute payment. $9,800. You can withdraw $9,800 every month for 25 years. Now we're getting into like the hard stuff, right? So it is, but it's fairly common to get these types of questions, and so you want to be comfortable with them. Okay, one more question, and then this first lesson will be done. You just borrowed $100,000 from JK Bank, and the bank has quoted you a rate of 8% compounded monthly. You will repay the bank with monthly payments for the next 10 years. How much will your payments be? Very, very common question. We're actually going to expand on this in the next part. But it's a loan. A loan with equal periodic payments. So by definition, this is an ordinary annuity because the payments are constant. Like you're going to make the exact same amount. Your payment will be the same amount every month. It ends after 10 years. So when you're dealing with this type of thing, it's really straightforward. This 100K is your PV. You guys can even pause the video and try and do it. 8% is your APR. I know that because they said 8% compounded monthly. As soon as I see that word compounded, I know this is an APR. So 8 IY. My compounding frequency is 12. And my payment frequency is also 12. 0 future value, and N is 10 times 12, right? I'm making monthly payments for 10 years. Monthly payments, 12 for 10 years. Compute PMT. $8,000.78. Just punch it in a second time to be sure. Yeah, it's wrong. That should be 12. Okay, before hitting compute, I need to go in and change my PY and CY to 12. So 12 and 12. Compute payment. So there you have it. Okay, so that is the end of this first lesson. Before you watch the next video, which will be a little bit more advanced, take some time to practice this. If you're in COM 221, then this video pretty much captures the majority of what you need to know. The second half is really if they feel like throwing some curveballs. If you're in COM 308 or COM 309, the second half of the TVM chapter is as important as the first one. You need to watch it all the way through. If you guys have questions at any point, you know where to find me. My contact info is everywhere. You can reach me on Instagram at prof.johnk. You can send me an email. You can message me directly here on the platform. Thank you very much, guys. Let's have a great semester. See you soon.